Okay. Example 1. Let's do this. Division algorithm. It looks really simple, but sometimes you just don't realize you need to use it, or you have to use it. So this is saying that if A, B are natural number, then you have a unique pair. Can't see it for some reason. Then you can have, there is a unique pair of integers R and Q, where Q is greater than or equal to 0, R is in between 0 and B, so R cannot be bigger than B, such that we have A equals to QB plus R. So this is a quotient, this is a remainder. Straightforward. Use the division algorithm theorem to show that this equation has no integer solutions. This is pretty much similar to the one you guys did in lecture, and they put it on the quiz last year, and half of the students cannot do it. Really sad, by the way. So, tell me, how do we do this? You all did it in lecture, by the way. So tell me, how do we do this? Take 4 to the other side, yeah. So x squared equals to 3y minus 3 minus 4, so it's 3y minus 7. What do we do? I think there is a misunderstanding here. I don't know what you guys are talking about. What do we do next? What do we do next? Come on, come on, come on, come on, think, use your brain. Use your brain. If you don't use it, it's gonna become what? Use your brain. Isolate the integer. We just moved that to the other side. Why do you want to isolate? Starting from here, what do we do? So you have this equals to this. What do we do next? Factor the goddamn 3. Okay. Cool. Let's factor it out. So this can be written as what? How do we factor it out? 3y minus 9 plus 9 minus 7. So it's 3 times y minus 3 plus 2. What do we do next? You don't want fractions because we're talking about integer solutions, Omar. Does that make sense? Why do we not use 7 over 3? Because we're talking about integer solutions, so you don't want fractions anywhere. You want integers everywhere. So now we have this. X squared equals to this. What do we do next? What do we know from this? Let x equals to 3m, where m is y minus 3. You're confused how I factor out 3. So I know I want to factor out 3, so I want something that's divisible by 3. So I know that 9 is divisible by 3. So I just minus a 9, and this is like plus 0. Well, you don't have to use 9. You can use other things. So for example, stop. You use 6. Yeah, you can use 6. But the main thing is, you can use 6. So you can use 6 plus 6 minus 7. So the main thing is, the reason I chose 9 instead of 6 or 3, those are all good, but if you use 6, that's gonna be 3 times y minus 2 minus 1. This is a negative number. I want a positive number because we're talking about the remainder. Does that make sense to you? Because you don't want remainder -1. You want a natural number as a remainder, right? So after you divide by 3, the remainder is 2. So you don't want -1 because what is remainder -1? So that is the main reason I chose 9 instead of 6 or 3. Yes, exactly. So let's get, we got here already. So this implies that implies the remainder of x squared when divided by 3 is 2. Does this make sense for now? So far, so good? Okay, so cool. So now we know that if you use this divide by 3, you'll get 2. Now think about the x squared itself. So we used this side already, so let's ignore this. Look at this side. Look at your left-hand side. X squared, right? It can never have remainder 2. That's correct. But how do we reach there? So by division algorithm, we can write by division algorithm. Algorithm. We can write equal to q what 3q because I want divided by 3, so 3q plus r. Okay, so my b is 3 here, r is just any. Make sure you define your q and r. Q is integer, r is what? What can my r be? Not just it's 0, 1, 2, that's correct. R is 0, 1, 2 because you divided by 3, so the remainder can either be 0, 1, or 2. Okay, so what's my x squared? X squared is 3q plus r squared, which is 9. Oops, my 9 and q look the same. 9q squared plus 6qr plus r squared, and remainder, oh, not remainder, remember, remember, you want to write it as 3 times something plus something, so you know the remainder, right? So again, we want to factor out 3. Does that make sense? Why do we want to factor out 3? Yeah, so it's in the same form. So you, exactly, so we know what the remainder is, so you can compare the remainder. So this is 3 times 3q squared plus 2qr plus r squared. Okay, so that means when x squared is divided by 3, the remainder is going to be r squared. So what can r squared be? Anyone? What can my r squared be? 0, 1, 4. We know that r squared is going to be 0. Oh, I said 0, I wrote 1. 0, 1, 4 What does it mean? It's never 2, but what about 4? 4 is bigger than 3, so we need to change it to what? What's 4? 1, right? So this means, this that implies that, oh, that 1 divided, I can't write today for some reason. 1 divided by 3, we can only have remainder 0 or 1. So this is a contradiction. Before we said it's 2, but now we said, oh, it can only be 0 or 1. Okay, so this contradiction. Contradiction. Why not 4? Because 4 cannot be a remainder after divided by 3. Yeah. Let me write the contradiction specifically. Cannot be 2. Okay, so this is a contradiction, and this is our proof. Question? Clear or no? Clear. Cool. Let's do GCD. What's GCD? GCD is the greatest common divisor. And what is the smallest number you can have for GCD? 1. Okay, 1. Okay, then what is GCD of 0, 8? Okay, cool, nice. Okay, because why is it 8? Why is it not 0? Greatest common divisor. Okay, cool. Right, because well, 8 is a divisor for 0. Anything is a divisor for 0. Okay, so the biggest one here will be 8. Nice. That's great. If GCDAB is one, we say that they're relatively prime. Feel like we've seen this before when we do contradiction proof before. Remember, they said, "Oh, proof this does not have a rational solution," and you suppose it has a rational solution. Where we said, "Oh, when we want the numerator and denominator be relative prime, so that means their GCD equals to 1." Will we ever get a GCD of 3 numbers? You could have GCD of 3 numbers. Why not? Why not? Why not? Okay. Proposition 6.2.2 says let A, B, and K be integers, where A, B are both non-zeros, and GCD of A, B equals to GCD of A minus KB and B. This is quite useful in many cases when they ask for the GCD of 2 numbers. It's probably in the quiz. I don't know what your quiz will look like. I will see tomorrow, but not today, not now. We don't know. Okay, only the professors know. So ask your professor. Example 2, we don't have time to do that. So with those identity, let's look at this. We'll do 1 and 3. 1 and 3. Benzos identity says if A and B are two integers, not both 0, then there are m and n in integer such that an plus bn equals to GCD mn. Now, you can use this to solve this equation. How do we do this? Any suggestions? Any suggestion? How do we approach this? GCD proof by miracle. No, it asks you to figure out what your x and y are. You need to solve for x and y. Did I wrote it wrong? It's probably a typo. My bad. Equals to y and 15 equals to a and 1. Do GCD 61, 5 and 6, 8 and 1, 8, 10. That is a correct suggestion. So let's figure out the GCD first. How do I figure out the GCD? What do I need to do? What algorithm do I need to use? Use a GCD calculator online. If you do that, you cannot figure out how to do this question. Okay, we see Euclid's algorithm, that's correct. So let's use okay. So we have 8, 10 equals to 1 times 615 plus what is this? 195. Okay. If I made any computation error, you need to let me know. Now, what's my next line? 615 equals to something times 195. What's my something? 3 plus, so the last digit is 5. 7, so wait, it's not 5, is it? No, it's not 5, it's 0. Oh my god, what did I say? It's 5. Last digit is 0. 1, so it's 3. Okay, next 30. Okay, so I'm right. 195 equals to 6 times 30. This one is easy. Plus 15. And 30 equals to 2 times 15 plus 0. So what's my GCD? This hurts your brain. Why? So basically you're doing this. Move this to here. Move this to here. And so on. See? GCD is 15. So we know that GCD of 615 and 10 equals to 15. Now, by the identity we have here, so I think this is how you spell it. Don't we already know that? You know that? I didn't know that. By the identity, we know that there exists an in integer such that 15 equals to 615n plus 810n. Now what do we do? What do we do, guys? What do we do? What do we do? What if you find out your GCD is different? Yeah, sometimes they don't give you 15 here. They can give you 30 here, but the GCD is not 30, but you can still solve it. Substitute the equation we have. Where do we substitute? How do we substitute? 15 equals to something. That's correct. Okay, so we would have from before we have 15. So let's call this 1 because I'm using 1. 15 equals to 195 minus 6 times 30. This is by equation 1. And then 30 equals to 615 minus 3 times 195. This is by equation 2. Okay? You can open the brackets. You have 195 minus 6 times 615 plus 18 times 195. So this is 19 times 195 minus 6 times 615. And 195 can be substituted by the third equation. So this is, move it to here, 19 times 810 minus 615. Minus 6 times 615. So eventually you get 19 times 810 minus 19 minus 6. So minus 19 times 615 minus 6 times 615 equals to 19 times 810 minus 25 times 615. Question so far? I will answer a question in a moment. But here, do we have any question? What did I just use? Oh, I should. Here should be 3. Whatever you used, you have to cite it, yeah. Otherwise, you might lose marks. Why is it sad? They created this, so you should give them credit. Otherwise, it's plagiarism. It's not really plagiarism, but you should give them credit because, well, they figure it out. So yeah, so x is negative. So back to here. So x is negative 25 and y is 19. Substitute to the next line, I mean here to here. I opened the bracket. That's all I did. I opened the bracket. Now, I have another question for you. What if, okay, here is another question. What if I change the question from integer to natural number? Now think about what you do. I'll make a few changes and you tell me what you do. You can have negative, that's correct, but how do you make it positive? That's my question. It is possible mathematically. Did someone just stop in? It is possible mathematically, but how exactly? Oh, never mind. This one is not possible mathematically. You're right. This one is not. But let me give you another one. I should change it. You're right. Sorry, my bad. Let me find another one so that it is possible mathematically. Let me give me a bit time. Okay, what about this? For this one, let's change 15 to 30. Now what do we do? No, I erased it. I erased it. So tell me if I change, I only changed 15 to 30, what do we do? Where is the question I want to do? Can't find it. Oh, I found one that I can ask you. It's the same thing, just multiply both sides by 2. Exactly. Exactly. So what does this tell us, guys? When do you have solution? Yes, exactly. If this, it's the other way around. It's the other way around. If this is a multiple of your GCD, then you can always use this method. So it's the same thing. Does that make sense? Because well, if you multiply by 2, the whole thing, this will get to 30. So your x and y. So, okay, let me ask you. If I change this to 30, what's my x and y? Someone tell me what's my x and y. Negative 50 and 38. Okay, cool, nice. Here is another question. Are there any other integer solutions x, y that can solve this? How did you get it? You can just mess around with the Euclidean or solve by back substituting less. What do you mean back substituting less? How exactly do you get another pair? That is my question for you. We'll leave it here. I'm not gonna take it up, so you figure it out yourself. Figure it out yourself. And my hint is you don't really need to go back. You can just start from here, from the last step. Add multiples and subtract. That is correct. Okay, that is correct. Someone's getting on the right track. But we're not gonna take it up. We'll do another question because we have 10 minutes left. Come on, do another question. Let's do, what do we do? Do four? Let's do four. Four. How do I do four? No, you don't. You don't need to use Euclid's lemma. You just need to use whatever we just talked about. Don't guess. Use your brain. You have one. Come on. Everyone has a brain. Use your brain. There is no prime number here. You don't even know if A and B are prime numbers. Okay, I'll give you 1 more minute to think about this. 1 more minute, we'll take it out. Let's prove by magic. No, I'm kidding. It's not proof by magic. Can you calm down, Brownie? Come on. Anyone? Suggestions? Bring for the final and the next quiz. Can't do that. I need my own brain. Brownie, stop! You guys hear him running around? No, I thought you can hear everything. He's like running around. I don't know, just crazy, just being crazy. Do you wanna see my cat, by the way? I don't know why it's so random. Let me get my cat because she's right next to me. So let me get my cat. Oh, puppy. Say hi. You can go back now. You're too heavy. Oh. Okay, do this. Now let's prove by magic. Use magic. Proof. Then GCD of AB is 1. By those identity, there exists PQ in integer such that AP plus BQ equals to 1. Also, what's also? Also, since A divides M and B divides M, we can write M equals to AR equals to BS equals to bullshit or some RS in integer. Okay, now what do we do? Now we multiply by M on both sides. APM plus BQM equals to M. What do we do next? We substitute. So this is going to tell us APBS plus BQAR equals to M. So AB times CS plus QR equals to M. So what does this mean? This means AB divides M. I will post both recordings, that's correct. Are we good? I might do a short example one. Last pre-quiz, yeah, I can release that. I'll explain again, just hold on. Okay, last step. Oh, where is it? Here. Oh, they are all natural numbers, so you can write natural numbers. I didn't realize they are all natural numbers. So change this to natural numbers. Okay. 4. Let me explain. Did we get from here to here? Yes or no? There is no you hope so. Do you hope so? You can do your quiz. You can hope. Yes or no? Yes, okay. This follows directly from the identity, okay? And now, what about this to this? Yes or no? Okay, so we understand everything till here. What I did next is I multiplied this by M on both sides. Okay, what about I write it like this? You understand it now? The logic behind it. I have an equation here. I have a and b, but I don't have m. So that's why my internet connection is not stable. Can you guys hear me? That's why I multiply by m to add my m there. Does that make sense? That is my logic there. So yeah, I'm just trying to make m to be in my equation. So I multiply by m. Now I know that m equals to AR equals to BS. Why did I put BS here? Because I want AB together. If you put A here, then it's AA, it's useless. We want AB, right? So that's why we replaced BS here, AR here to get AB. So we can factor out AB and done. Exactly. So again, I think I mentioned this many times. The questions themselves are not important. The actual important thing is the logic behind it. What technique do we use? How did we come up with the question? So when you see solutions, you should ask yourself, why do we do this? That's how you learn this course. You need to think. Use your brain. That's how you ace the course. Use your brain. Where did PS? You don't need it. This is just a natural number. So with this, you know this divides this. Well, whatever it is, it doesn't really matter. We know it's a natural number. That's all we need. Cool. We'll stop here and take a picture together. So turn on your camera.